Good morning, everyone. My name is Chris Gillis, and I'm the Manager of Applied Research Business Development with Durham College. And Durham College is one of the partners in the Durham Regional Technology Development Site that is part of the Autonomous Vehicle Innovation Network. And I'll be taking over the role of MC today from my colleague Richard Dunda of the Hamilton Regional Technology Development Site, who did that yesterday, and Richard did a great job. So I'd like to welcome everyone to day 2 of the 3rd annual Future of Transportation and Mobility series event, where we are exploring the future of goods movement and the supply chain. And just a note, if you were not able to join us yesterday, I wanted to let you know that Chris Keefe of Arrigo gave an enlightening keynote on the application of connected autonomous vehicles in the airline industry. Corey Clothier of Stantec gave a global panoramic perspective on how connected autonomous vehicles are rolling out, and our panel, moderated by Gatic and representatives from Loblaws, Purolator, and McMaster University, exposed a number of really interesting key issues going forward. And I just want to remind everyone that these proceedings are being recorded, and they'll be available on the CITM and Durham RTDS websites after this event. So today's theme is that of the role of data, analytics, cybersecurity, and AI in connected and autonomous goods movement. And so to kick off day 2, it's my pleasure to introduce Cyrus Tahani. Cyrus is Chief Digital Officer of the City of Hamilton, who will deliver the opening remarks for today's proceedings. So Cyrus, the stage is all yours.
Thanks, Chris, for that introduction. On behalf of the City of Hamilton and Mayor Fred Eisenberger, it's my pleasure to provide some brief opening remarks and welcome everybody to day 2 of the Future of Transportation and Mobility Conference. I guess though it was only last January, seems like much longer ago, we had gathered at Hamilton's Warplane Museum for last year's conference, amazing venue to talk about that future of mobility in the presence of aviation history. I won't dwell on the good old days, where you could speak to people in person and shake hands and exchange business cards. But, instead, I want to congratulate the Center for Integrated Transportation Mobility, and all the event partners involved today and over the past yesterday and tomorrow for moving this conference to a virtual format. And I had a chance to catch some of yesterday's agenda and some great discussions and presentations, and I know there's more still ahead today and tomorrow. Hamilton, of course, really proud to be host to one of the 6 AVEN regional technology development sites. I think it's obvious that would never have been possible without the great work and effort by the entire team at CITM and our RIC Innovation Factory, and of course in collaboration with AVEN and the province of Ontario. I know the city's been working closely, myself included, with the team at CITM, and that partnership, I think, speaks to the broader innovation mindset here and in Hamilton. I have a pleasure of chairing our City Smart Community Working Group. We have partners at the table that include, obviously, CITM, Innovation Factory, McMaster University, Mohawk College, our Hamilton Utilities Corporation, HCE Telecom, our economic development team, and a few other partners. And this group works collaboratively to look for some of the innovative opportunities, in line with some of the topics that are being discussed at this conference and how that can be supported and expanded. The connected vehicle testbed sites, and even the current development plans for a remotely piloted aviation system, or more commonly, I guess, drone research park, are just some of this innovation work that's occurring amongst this partnership. And I think it's this collaborative partnership ecosystem that exists here in Hamilton that I feel will be a key factor to help support the development, testing, and piloting of these rapidly changing supply chain landscape and the opportunities for both for business and economic growth and diversity that it presents. Hamilton, obviously, if I can go on a little bit of a spiel, is a key gateway for goods movement. We're located obviously in the GTHA, the center of the economic hub. We have access to a wide range of transportation, passenger, e-commerce, heavy, project, cargo, commodities. We're one of the only handful of Canadian cities that has all 4 major transportation modes within our municipal boundaries: road, rail, air, and port. We're truly a multimodal transportation center. We have the airport, we have the port, we have CP and CN rail lines, and intermodal facilities with connectivity to all the major highway cities which really makes us well positioned and also drives us to make sure that we're thinking about what the future supply chain landscape looks like. Now, on top of that, you layer being home to McMaster University, which is Canada's most research-intensive university. We have Mohawk College, one of the top industrial and applied research colleges in the country. We have McMaster Innovation Park, Canada's premier research innovation park supporting startups, businesses, and research. There are a broad range of opportunities around autonomous goods and services movement. Hamilton, I'm proud to say, was also named one of the top 7 communities by the Intelligent Communities Forum for 2020 for its work across multiple domains that include, connectivity, knowledge workforce, innovation, digital inclusion, community education, and engagement and sustainability. Of course, all this work is not without its own challenges. I'll be the first to admit that working sometimes with a municipality can have its own unique set of challenges, whether it's legal, privacy, cybersecurity, or change management. These are all part of the learning curve associated with any smart city or CAV-related technology deployments. But I think also with some of these challenges come some really big opportunities, whether it be pilots or living lab collaboration opportunities, improving communications, improving services for citizens, getting better data, making sure that data is secure, or even creating education programs to train and develop the required career pathways that we're going to need to deal with this new future technology that's coming our way. Maybe some of these partnerships can include tech companies and already do, utilities, academia, and industry. And all of those kind of coming together will be a critical component for our present and rapidly approaching future of transportation and mobility and autonomous goods and service deliveries. So with that said, in closing, I want to thank for the opportunity to kick off today's exciting agenda, and I'll pass things back to Chris. Thanks, everyone.
Thank you so much, Cyrus. I really appreciate those opening comments, and specifically to highlighting the whole idea of collaboration. I think the whole Autonomous Vehicle Innovation Network is really all about that, and certainly this event too. So I just have a few housekeeping items to cover very, very quickly before I introduce our keynote. I just did want to remind everyone that this event is being presented by the Innovation Factory Center for Integrated Transportation and Mobility, which we refer to as CITM, and they are the Hamilton, Rick, and then there is Ontario Tech, the Spark Center, and Durham College. We are the Durham Regional Technology Development Site, and of course in collaboration with the AVIN, the Autonomous Vehicle Innovation Network. I just want to remind everyone that all of today's presentations will take place here on the main stage, and that's where you are now. And if you have any comments, please put those in the stage chat, and that's to your right-hand side. You'll see the word stage there. Also, just a reminder, speaker bios and all the event information is on the event website, so please check that out and it'll allow you to connect with people you may wish to network with. And also a thank you to Solano, who is live streaming the event, and a reminder, if anyone is enjoying this from a live stream, we'd ask you to please feel free to go to the website, the event website, and register for the event. So now it's time for our keynote, and that's titled Automation and the Internet of Things, the Death of the Security Perimeter. So it's my pleasure to introduce Eric Matthews. Eric is Chief Technology Officer and Co-Chief Cyber Strategist with Parabellix Cybersecurity, who will provide you with, I think, a leading edge lens on where cybersecurity is and where it's headed. So Eric, the stage is yours.
Good morning. Thank you. Great to have everybody here. I can't see any faces, but that's the nature of how we're doing things right now. I'm going to share my presentation here briefly. I just have to get that up. All right. So it's great to see everybody here. Like Chris said, I'm Eric Matthews. I'm the CTO and co-founder of Parabellix. We're a Toronto-based information security consulting firm. I've been involved in IT security for about 20 years, time's been mostly split between doing penetration testing work. Sometimes people call it white hat hacker, where we're breaking into applications and networks to test security systems, and also security architecture and implementation, where we work to secure the same networks. We started Parabellix a couple years ago, recognizing that there's some significant changes going on in IT right now, and I think we have a good pulse on that to help organizations better achieve their security goals through that shifting landscape. I know today, I think in this conference, we're primarily focused on automation and autonomy, and that's an important area of development in computers and technology. But realistically, the trends that we're going to talk about that surround autonomy and the Internet of Things are prevalent in IT in pretty much every area. I'm going to go ahead and walk through how the fundamentals and this fundamental shift in IT really kind of manifest as we work through technology's growth and through the next phases. So to start, autonomy is really interesting. It has become pervasive in society, and I was reading a book recently by William Davidow called The Autonomous Revolution that has made the claim that autonomy is the third significant phase change of human society. That is a pretty profound statement, but he claims that we went through an agricultural revolution, we went through an industrial revolution, and the autonomy revolution is just as significant to the future of humanity and technology. So with that said, we may be at the leading edge of what may become the most significant changes to human society in generations. We want to keep our finger on that. We can't always predict what's going to happen next, but really working through that and being on top of it is the best approach we can take. This really brings us some new challenges and some new risks. People here will already know this. You guys are aware of automation, but I just wanted to play this briefly while I talk. I think autonomy has been viewed in the past as something that is coming, something that is in the future, and I think this is not going to work. So we're going to go ahead and just talk about it. There we go. So realistically, autonomy is already here. We see it in the environment. We see it in the around us every day. And it's not distant future. What we have on the screen right now is, I think, something everybody here is familiar with, but this is a video. I'm not going to play the whole thing. We'll just look at a few seconds of a vehicle driving itself with zero assistance from a neighborhood in San Francisco to a neighborhood in Los Angeles. Obviously, that's not the mainstream right now, but it is available to the public. People are using it, and it will become prevalent in the near future. And autonomous vehicles are obviously not the only target for autonomy. I think they're a very visible and socially important aspect of it. So they serve as a bastion for that in the public eye. But frankly, they're coming sooner than most people realize. So there's an idea I'm calling pervasive autonomy. That means that autonomy and the proliferation of small devices, or the Internet of Things, is building itself into every aspect of society and becoming more and more invisible as it becomes smaller and more capable. This concept of pervasive autonomy is characterized by a couple of independent factors. Number one, the increasing independence of action. This is significant because devices will become increasingly able to make critical decisions and control more and more critical infrastructure. That happens today with some oversight and operation from human operators, but in the future, that's going to move into more and more unsupervised decision making. It's also categorized by greater connectivity. Devices spread across the world, distributed networks, public spaces. Often these devices will be wireless, they may be out of sight. And finally, a distributed deployment. And what I mean by that is devices will become smaller, they will become more mobile. The application components will distribute out to the edge of the network. And in addition to that, any core services we have will likely be distributed and deployed to cloud environments. The mix of these three ideas really provides us with huge productivity benefits. They're all driven by an increase in capability. but they also multiply the potential risks posed by these systems. So for the next little bit, we're going to dive into some risks and approaches for addressing risk in this kind of environment. Parts of this discussion will be a little bit technical, but I'll try to keep it at a level where we can talk about it regardless of your background. So right now, security is a pretty significant component of the IT industry. 2020 was a hallmark for IT security, obviously, with the changes in how we all do work and how we work from home and how we present at conferences. There were over 4,000 publicly reported breaches. These aren't, there's obviously probably significantly more than that aren't publicly reported, but these are the big ones. Over 40 billion records exposed. And 2021 probably will be the first year we exceed $1 trillion in global cybersecurity spending. Autonomous and distributed systems are the next front. They really are, and that is becoming more and more clear as they become more prevalent in society. Another component I already mentioned of that, and this is throughout IT, it's not just in autonomy, but it's an important component to be aware of. 97% of businesses currently or plan to use cloud resources. 70% are currently shifting a significant fraction of their computing power to the cloud. That means we need to have a different approach to security, and the mindset of security means that we can't rely on our old-fashioned infrastructures. We need to start thinking about cloud security, how it works in exposed networks, and what it means to transport and store data on untrusted locations and in public. So the old model of network security, and honestly, this is taken from a current security vendor's sales material, is to have your servers, your people, your computers behind a firewall. You stick everything. I call it the old crunchy, the old eggshell or the crunchy shell. You build a hard perimeter, and then everything on the inside is just sort of trusted by default. This is the old model, frankly. Your 90s IT guy probably still advocates this, but hopefully people have started to understand that this is in the past and to a large degree, especially prevalent. Excuse me. Especially obvious when we go into IoT and autonomous devices, anything that's distributing their power to the edge. Imagine we get a fancy new thing. Your 90s IT guy might just say, plug it into the switch. It's on the network. It's fine. Don't worry about it. And this is probably still prevalent in areas, even in areas of automation. It might include in manufacturing. It might include areas around other areas that have an internal network that you can trust. Sometimes maybe the 2001 IT guy says, let's make a separate VLAN for your IoT or for your automation or for your SCADA products. That's fine, and there's nothing wrong with network segmentation. In fact, the smaller the network segment, the better. But the future is microsegmentation or zero trust. And fundamentally what this means is that every device is its own security bastion. It doesn't trust anything around it, and it's pervasively connected. This is really how things are moving. When we see devices that are mobile, we see devices that are independent, we see devices that can move in between networks and use public spaces and public networks. Each device has to serve in a manner of speaking as its own security principle. So I call that the death of the security perimeter. And fundamentally, the future is remote, the future is cloud, the future is internet accessible, the future is distributed, and the future is public. That's pretty profound, I think, a shift in how we do security and how we do IT. It's important to recognize that the core of the network, the sort of internal component, isn't going away, but it's going to be a significantly smaller fraction, and in some businesses, it's going to be zero. So what does that mean to have pervasive autonomy? How do we, how does that change security when we ask the question, what does it look like to have a secure environment in this? What are the changes? Why are we addressing this? And I think there's a couple of points here. Number one, distributed endpoints, something we talked about earlier, they increase the attack surface significantly, meaning that instead of a server with a couple of terminals that are on a trusted network, you have, say, tens or dozens or hundreds or maybe even hundreds of thousands of devices deployed in a public space, in the field, on a street corner, in every conceivable industry. In addition to that, autonomous systems increase the sensitive data and the value of that data loss. When a system is able to collect enough data to make intelligent decisions about its environment, it clearly has a significant increase in both the quality and the quantity of the data it's storing. Also, independence of action means that these devices create risks to health and safety to other areas. They're able to do things, and that's their purpose, and that's the goal. And we want to enable that as a security person. My job is essentially to secure things in an enabled way, so that we can provide, what we call enablement, to be able to say to a business or to a designer of a new system, to say, yes, we can do that. Here's how we do it securely. And finally, obviously, I think we mentioned extensive cloud deployment changes the application residence and sovereignty. The idea of data residence and having the data, quote, on our network is fundamentally challenged, and something we need to continue to address. So, talking about these increasing connectivity, I'm going to dive into a little bit more detail on each one before we talk about the solutions for them. But increasing connectivity is really challenging. It may be deployments of 5G, it may be mesh networks, it may even be like personal area networks or things like that. Bluetooth, Zigbee, all of the other solutions that are out there for various kinds of IoT devices. But realistically, what they do is they expose greater attack surface. Again, the likelihood that devices are discovered by attackers is increased dramatically. Whether that's a smart meter on your home, which is a great example of increasing the attack surface. Suddenly you've gone from a device that used to just be a set of mechanical switches and dials. You really can't attack it in any way other than hitting it with a hammer, to a device that's doing a meshed network to communicate its behavior, and maybe even take commands from the utility authority back via some sort of backhaul on a Wi-Fi or 5G network. That increases the attack surface and the ability for an attacker to target these devices significantly. Again, increasing independence drives more and more risks. There's a couple of great examples of this. In fact, 3 weeks ago, there was an attack in Florida against the Oldsmar water treatment facility. This was in the news. You've probably heard about it. But an attacker managed to gain access to a water treatment plant that did water treatment for drinking water in a town in Florida. And they increased the sodium hydroxide concentration in the water by 100 times, which is potentially lethal. That fortunately was noticed by the staff at the water treatment plant, but the ability to execute changes like this remotely using digital systems, using remote connectivity, the likelihood is that it was somebody overseas, that we're never going to find out exactly who it was. That's pretty profound. That you can, and in this case, I understand that there may have been some limitations built into the pumps and things that may have prevented that. But regardless, the fact that this even was a possibility is pretty profound and worth discussing in more detail. Beyond that, distributed deployment. Again, we talk about cloud, and I'm going to keep bringing it back to cloud because this is what we talk about every day at Parabellix. We have every business we're working with, every business that we see is every organization that we see, whether it's municipal, whether it's research and manufacturing, whether it's universities and everything. It's all distributed, and the pandemic has only accelerated that dramatically. Cloud systems have some unique risks. They use untrusted networks. They store data in untrusted locations, or somewhat untrusted locations, less trusted anyway. And this exposure of that data is often done using programmatic means instead of like a long trusted concept, like say an SCP server or something that's been used for 25 years, as we might do on the internal network, or NTP or Windows file shares, SMB shares. Now we're seeing those done with APIs that are custom developed. There may be web components associated with them. Those have significant risks because we're exposing data via custom code and things that are newly developed and have to be fleshed out. Those standards are continuing to develop, but we'll keep an eye on that in the industry. So there's a couple of scary things that we've talked about so far. So, security seems daunting. What do we do, right? What are the solutions? That's going to be the question. That's what everybody's here to see. So let's talk about how we come to solutions. First of all, when we're coming to a solution, we're fundamentally trying to I think the most important thing, the thing you can't overlook, is addressing and understanding the threats. You really can't develop a mitigation strategy or any capability of fixing security solutions until you've understood your threat vectors and your vulnerabilities. So understanding these threat vectors, we look at a couple of areas. This is specific to autonomy and pervasive autonomy in the Internet of Things. We see some areas that come out. Number one, malicious intelligence is a risk. Data security attack is a risk, and we'll talk about each one of these in a few minutes. Code security threats is another area I'll talk about. System security and endpoint hardening is another one, and then cloud environments in general. When we're approaching a unique environment, we often will do a threat risk assessment, a TRA, and there's a couple of standardized processes. In fact, the sort of world standard for threat risk assessment came out of the RCMP in Canada and is used worldwide, and it's one of the methodologies we employ to help organizations understand their risk profiles when it comes to various different kinds of IT systems. So one of the other things that I want to really emphasize, and this is probably not new, but it's important to build this into your mindset for security. If you are in charge of electronic systems or of IT in general, or you're worried about those, it's really, really important to understand that security is not something that you can bolt on. It's not an addition. It's not something you do after the fact. You don't get to do that anymore, especially in this new environment of zero trust, distributed networks, autonomous endpoints. Adding security after the fact isn't really even practical anymore when you have remote and distributed endpoints. You really have to design for security, you have to architect for security, and you have to develop, and that means software development for security. Security is not buying a new tool. So going into a couple of the specific areas, this is one of them we talked about in our threat list, and data security is significant. When we deploy these solutions to endpoints distributed around the world, we have significant data security concerns. The data may be within these local devices distributed everywhere. Attackers may even have access to those devices. They may be in their home or in their car. They may have time to inspect and build attacks against those devices, maybe even months or years. They also have potentially electronic access to data. Again, we use the example of a vehicle. That, everybody has the vehicle in their garage. They can take as long time as they want with it. They also have electronic access to some of that data. They may have an app that gives them an interface to their car. Their car may be communicating to the network via Wi-Fi or other things that they can get in and snoop, depending on the security of that platform. And there's also physical security, meaning in the past we treated physical access to a device as essentially breaking the device. The typical advice 20 years ago was if the attacker has physical access to your machine, game over, it's done. But we can't afford to do that anymore. That's not a realistic approach, because the attackers do have physical access to autonomous systems, and that will not change. So what do we do about it? I think strict control of endpoint data is one thing that we have to keep in mind. We need to be, first of all, again, awareness is something we talk about a lot, aware of data locations and types. Those data locations and types is something we have to really put our finger on. Robust authentication and access control of data is another one, making sure that only the correct people have access to the system. Beyond that, we have data encryption, and this is of increasing importance, even in your standard IT systems. I think if you have a diligent IT staff, probably your laptops are encrypted, your servers, your data stores, your databases, and different types and levels of encryption have different advantages and drawbacks. We don't really have time to go into the details, but in an autonomous distributed device, we want to be able to encrypt the local data. What that can be done using cryptographically secure controls that use, for example, keys that are embedded into hardware chips. That increases the difficulty of breaking that encryption to the point where it's usually not practical for almost any attacker. And then we also have encryption in motion, which is essentially the transport encryption for your devices to try to send data back to the networks. This is again true of everything from websites to laptops. A traditional solution would be like a VPN. This is something that's still viable, but it's not great. A better solution is to just build the idea of the software only, that it only ever functions with encryption. The basics of like a modern version of TLS, which is what is powering our chat today in the secure web and HTTPS, is perfectly adequate. TLS is the newer versions of TLS. Let me be really clear about that. The old versions are pretty bad, but the newer versions of TLS, like TLS 1.2, 1.3 especially, are very secure and have perfect cryptographic perfect forward secrecy and some other controls like that help build that security in. So even if you have access and pervasive access to a device, it's very hard to break or impossible with current known techniques. Malicious intelligence is the other area that we identified. What does that mean? Well, autonomous systems are able to make decisions based on potentially malicious or modified inputs. And with their power, we have the incentive of users to fake those inputs. A couple of great examples here are I think the Stuxnet attack in Iran was a great example of this. Stuxnet was a malware developed by the Western governments, probably Israel, but that targeted Iranian nuclear power plants. It was distributed globally and infected computers all over the world, but its primary goal was to mess with the input-output cycle of centrifuges in Iranian power plant and uranium or plutonium. I forget, uranium or plutonium refinery plants, and those fundamentally sort of took the inputs and gave them false data. So these sensors were reading that they were under speed even though they weren't, and they tried to accelerate, and they would accelerate to the point where they would be physically damaged. And there's some reasonable evidence that this actually was successful, which Stuxnet is one of the most remarkable pieces of malware ever written, in my opinion. And I could talk about it for half an hour, so I won't. But what do we, what does that mean? Do vehicles? Another great example is the Tesla phantom braking issue and other autonomous vehicles. They see a shadow in the road and they slam on the brakes. A potentially malicious one I also saw was a user putting up a road sign that said speed limit 180. And if the car reads that and just goes ahead with it, it's going to try to drive 180 on a residential street. That's very inappropriate and extremely dangerous. So what do we do about that? Well, we really have to design the systems for validating their inputs and outputs. A great way to do that is redundant automation, essentially checking multiple things. You may check an input sensor for this device, but you may also check, for example, a different kind of sensor, an optical sensor or a camera that can confirm that setting. Redundant sensors is essentially the same idea. And then you have fail-safe mechanisms and deny by default profiles, where you can build some hard limits or some configurable limits, if it's appropriate, into this software. So in your Stuxnet example, you may, if you're a uranium centrifuge developer, you may have thought to build in a maximum RPM at which you can't surpass, and then you can't be damaged by this malicious input. And the worst that happens is you wreck a batch of production. That's true of obviously any manufacturing and any other types of controls. The next area that we talked about was code security. Code security threats sounds a little esoteric, but it's a fundamental type of attack, and it's the sort of stereotypical attack that we think of when we think of a computer virus, a computer exploit. These are fundamentally tackling code security in a way that they're looking for vulnerabilities, they're looking for mistakes, and they're looking for oversights in the actual software code developed by the software developers who wrote the system. This sometimes you hear called buffer overflows. There's different kinds of attacks, obviously, buffer overflow, heap spray, etc. But these are fundamental to the development of the software. And code security really is inherent to the system. It's very, very difficult to add solutions to the top of a system that's already insecure. Not impossible, but there's limited viability in a lot of those solutions. So fundamentally, our solution is to ensure that there's code security throughout development. And we, Parabellix, we work with customers often in helping them develop a secure development lifecycle. And what that means is, number one, you build the security in mind, and that security is built into the software in layers as it's appropriate. This can include validating inputs. It can include doing work on controlling things like buffers and memory usage. You can also use secure frameworks that have memory protection controls in place. It also includes some other areas that we strongly recommend. There's automation that we always recommend. And automation, again, it's funny to talk about autonomy helping control the security solutions of autonomy, but it really is. We use autonomy all the time to help make processes more reliable, number one, and help make sure that processes are followed consistently. And using that automation, we can build our software development build cycle with automation in mind, and then include code scanning and code review controls, checkpoints, and actual tools in that process. And that's great. Code security tools, they're not flawless, but they're one of the most powerful ways to ensure that code security doesn't become an issue in an application, because they essentially can crawl through the source code, and you can have it do it on every build in an automated pipeline, a CI/CD pipeline, and that code security software can then be the arbiter or it can identify specific vulnerabilities and issues in the software, and then that allows the developers to fix that prior to having the software even finished. And then we also recommend, and we conduct a ton of these, is security audits on whether it's full applications or pieces of applications. And this is essentially looking from an external view. What does an attacker see? What are they able to do? And code security tools aren't perfect, so they're not the end all. And sometimes there's end-to-end logic flaws, there's authentication issues, or session issues that may only be uncovered by these kinds of audits. And so, regardless of whether we do it or there's lots of vendors out there that do that, but it's one of our core services, is this kind of periodic or manual testing of whether it's web applications or thick applications or other kinds of software, mobile apps even. That's something that is valuable to the life cycle of software. Another area is system hardening threats. So attackers often target default services. They target the system itself. So we may have built this fancy new automation code, but we may have, say, wanted to have an external API, and we realized we needed some software to do that. So we installed, I'll say, like Nginx as a web server or Apache. And those services themselves are potentially subject to vulnerabilities. They're also potentially subject to configuration or issues with their platforms themselves, whether it's Windows or Linux or other kinds of platforms, whether it's say a hardware driver, and sometimes it's as simple as leaving a default backdoor password on systems. And it's a little bit amazing how common that is, where a company will spend thousands of dollars or millions of dollars securing a piece of software, and then the integrator, who's unrelated to the company, goes to install it in the field, and they've left the backdoor password as just password or something like that. And sometimes those are even discoverable by attackers to decompiling the code. So they're a real risk, and we do see those in the wild, even in automation, but also in every other area of IT. So what do we do about that? Well, default to secure is a common phrase that I use, when talking to customers. We want to establish a repeatable and secure configuration. We want to make sure that when you're deploying something, if you're deploying one of something, that you've gone through checks and carefully evaluated something, and if you're deploying many of something, that you build one and you establish that sort of process and maybe a way to compare them to other builds, and then you're able to go out and build that in a repeatable fashion using some means of automation. And that includes, maybe testing or spot checks to be sure that those aren't overlooked. Finally, cloud security is another area. Keep bringing it up, but it's so important to the modern IT infrastructure. Distributed platforms, cloud. All of your central control points, all of your internal systems are moving to the cloud, frankly. And I think most businesses have said that they're intending to have almost all of their computing resources in a cloud environment. It's cheaper, it's faster, it's more reliable, it's more redundant, and it just has so many advantages. It's hard to justify, except in certain circumstances, but in general, it's hard to justify having a expensive building full of expensive metal with air conditioning and staff and all that other stuff. So realistically, what do we do there? I think in cloud, we have a couple of areas. You can't focus on the perimeter anymore. You don't get to have a badge reader that prevents people from physically accessing services. Now, your cloud security vendors generally have reasonable security, but how do you focus on your own applications in the cloud? A couple of areas that come up in this are identity management, authentication, authorization. Those are super important. And then application security. Again, it comes back to the same thing, but these applications are now, instead of just a component of the infrastructure, are the sort of arbiter of all of the access. They have all the data, they control all the data. So the application that you've developed to go into the cloud, or that you purchased to go into the cloud, is even more core than it was before. And then a couple of other things that I will continue to mention. Logging and monitoring is areas that are hard to overlook. That can, even in areas of automation, but also in general IT, logging, monitoring, understanding that is significant. And then automation, use automation whenever possible. If you can automate a deployment, it's better, because then you can do it again later and it's the same thing and you know that there's no difference. Even if you find security issues, you can go back to your automation and find out why they're present. That is a significant advantage. But you can also use automation for continuous improvement, and that's pretty great when it comes down to how continuous improvement, like what is the process of maturity? And when we look at environments, we talk about their process maturity sometimes, and I'm sure people in manufacturing have heard of this, but repeatability and then a focus on continuing improvement are hallmarks of a mature process, and that really speaks to security as well. If we can build a repeatable, automated process that then enables us to evaluate what we're doing and continuously improve, that's absolutely the best way to approach security. So I mentioned this already, but don't forget monitoring and logging. It's very important, and it can mean anything from an automated activity. For example, in our water treatment plant, if anybody changes the input of any kind of chemical, that should go to some kind of alert. That shouldn't happen without somebody noticing. And in this chemical plant, they weren't doing that. The only reason that they found it is somebody noticed, just happened to be looking at the screen as the person was clicking buttons. That was a fluke, and they got lucky, frankly, that nobody was injured. Logging and monitoring is so important, and automated systems don't reduce that, they increase it. And so number one, logging and monitoring actual IT components like authentication, system changes to the fundamental system, especially on these distributed endpoints that are often a sort of fixed device. They're not something that you're installing software on and patching often. Having a good idea of when those are changed may be critical to the security of the platform. And then, like I said, critical automation activities themselves, and what that means when, for example, somebody updates the software on a vehicle, or when somebody changes the parameters of a chemical delivery device, or there's obviously endless examples of that. So everybody here is, well, many people here are probably saying to themselves, but I don't build solutions, I just buy them and deploy them. Right. Yeah, that's exactly what the problem is in the industry right now, I think. And so we'll talk about that a little bit, because when you buy an endpoint, when you buy software, when you buy some sort of solution, a lot of times you are, as an IT manager, as a director, as a CIO, whatever your role is, you're purchasing products. You're not necessarily developing them. You're not building them. So what do we do? What do we do about all the stuff I just said? Fundamentally, buyers of purchasers of products need to hold the vendors accountable, and that means that probably need to include these general requirements in whether it's an RFC or an RFP or just a contract. Demonstrate to us that you've done your code security. Demonstrate to us that you've done your logging. Demonstrate to us that you've done your update process. Understand the life cycle and the end of life for devices. When will they stop being supported? If they're not supported anymore, you have to have a methodology for understanding that end of life and replacing those products if practical. But the reality is vendors get away too much with saying, yeah, we're secure, don't worry about it. We do good security, that's great. There needs to be more concrete requirements around that, whether that's demonstrating that they have security audits, talking specifics about their secure development pipelines, having third parties come in and check those. There's a lot of different ways to accomplish that, and probably all of them are appropriate, frankly. And also establishing a baseline of legal liability is important. Because the vendors need to be held accountable for these, because that's the only place you can secure these. There is no such thing as bolt-on security in this remote distributed environment. You don't get to add a firewall and an IPS and a spam filter, and the old-fashioned IT security controls. They're not really part of the thought process when you're deploying endpoints to the edge of a network, or when you're deploying an automation point in a factory or another environment like that. Your ability to control that is much more limited. So it's fundamentally on the developer to get to that, and you have to hold them to that. So I'm just going to do a quick recap. A couple of areas that came up often in everything we talked about, or most things we talked about, are these. And if you only take away 6 points for what your requirements for security are: robust authentication. Obviously, we talked about that, but that's so important in distributed and cloud environments. Data encryption. It should be employed everywhere with any sensitive data. There shouldn't be unencrypted systems. And the more accessible those systems are, the more encryption is necessary. System hardening obviously goes without saying. I think that's been a trend in IT security for years. That does apply to everything from IT systems, laptops, all the way through to autonomous endpoints and sensor nodes and things like that. Secure software development, I think there was a big focus on that here talking about it, but it can't be understated. It's really a core of this environment. Monitoring and logging, again, you gain a lot of insight. You really need to know about that, and that can really help you develop a secure process and continuous improvement. And continuous improvement, obviously, is the last one. So building these things together, you can build a flow of having secure by default, having secure installations, and then having a program of continuous improvements for security. So closing, security isn't a destination. There's no such thing as perfect security in a system that works. We can get pretty close, but if you build the system very carefully, but it isn't perfect. It never will be. So understanding that security is a mindset and it's a process. That means that developing by security, deploying securely, and operating systems with security in mind is something that you have to sort of continuously focus on, because security will continue shifting. Those aren't big changes. I don't see, as we move into automation, obviously there's a shift as we moved into pervasive and remote deployments, Internet of Things, and work from home, and bring your own device, and all of those other general concepts in IT. We see security continuing to shift along with those. And I think we'll see some security shifting as solutions become more and more autonomous, and more capable of really independent work. But we can keep our finger on it by focusing on continuous improvement and making sure that we've got a good idea of what those systems are doing, how they're deployed, and making sure that they're brought together in a secure way as possible. thank you all for sitting with me for a half an hour. We do have a little bit of time for questions, I think. So I'm going to be open for questions. So I have a question here. The question is, how does cybersecurity parameter affect aftermarket in the auto industry? So autos are, again, they're a type of autonomous endpoint, and they have some significant cybersecurity challenges. So building a computer system in an auto, whether it's part of the entertainment console or whether it's part of the drivetrain, I think, there's obviously some security there, but there's almost nothing stopping a vendor, a vendor or a third party, a customer from replacing that software. There's maybe that hardware, depending. There's ways to do that, but there's potentially legislation going in about right to repair and some of those other concepts, which may break some of the ideas about trying to lock in software on a specific device. So there's a little bit of a give and take when it comes to that. I think aftermarket components in the auto industry may be more challenging in an era where there's computer control of everything. That may functionally break a lot of things, but it also may open a whole venue and field of third-party componentry, and that's a real challenge, because if your fancy, I'll say Tesla just because it's a known brand, but if your fancy Tesla crashes, and then you crack the hood open and realize that you've got a third-party piece of software in there, it wasn't really a Tesla that crashed. Tesla made the wheels and the seats, but the autonomy may have been from a third party. So that's a pretty a significant change. But how does aftermarket change? That's a really deep question, but hopefully that I kind of captured a little bit of it there. What are your thoughts on cyber and physical attacks on automated vehicles, such as attacks on ADS? Okay, so there's a couple different kinds of attacks. There's malicious input attacks, which are the example of somebody holding up a street sign. And then there's also cyber attacks against the software itself, trying to, say, break into the communications protocols. Both of those are significant. Vehicles really should be working hard to prevent those attacks. In very few circumstances should a vehicle respond, for example, with an action that can endanger life via a remote message. In other words, there shouldn't be any scenario where a remote message that's coming into a vehicle can cause it to accelerate or brake. That's probably very inappropriate. There may be use cases for that. I know that Waymo's doing some remote control steering and things like that. We'll see how that plays out. The actual attacks sometimes are just proof of concepts where they're trying to break into a device to demonstrate that they can, control the windshield wipers or something remotely. And again, this speaks to some security issues, some code security issues in those devices if they're able to get into the system fundamentally and start executing actions that aren't supposed to be controlled by that system. It probably means that they've got some sort of code overflows, like a buffer overflow or a stack overflow, and that concept allows you to access hardware directly and do some other things. I think improving development in some of those areas, things like cryptographically secure communications with your hardware, is a really valid approach, and maybe something that we should be looking into, especially in life-critical and dangerous applications like that. So cryptographically signing requests that go to, say, a PLC or a controller that's executing some sort of important function, maybe a good approach to that. Another question, are we developing AI that helps security developers? Yeah, there are some solutions in AI that have made their way into IT. Some of the pervasive AI that we see, number one, we see some malware detection using AI. It's fairly immature at this point. I haven't seen any really profound ready-to-go functional demonstrations of that. But I also see some AI in log monitoring. That's probably the most effective area where it's working, and it's working in to help us digest a large volume of information logs of reporting, and say you have a whole IT environment that's collecting logs to a central location. You can use some AI tools that will help identify anomalies in that behavior, which can help you uncover attacks that may have been invisible from a rules-based engine in the past. And in development, I think there's some work right now, and I don't think it's very mature at this point, but there's some work on doing code security scanning and as a general concept. Instead of, right now we have a rules engine where we say, you know, here are 600 known attacks, we're going to scan for those, and some of those are very conceptual so that they can catch a lot of things, but that fundamentally means that those developers can there's some development work in the future toward AI that can help do that in a little bit better fashion. Sorry, I just got a note here that we're running out of time here, so I want to say thanks for everybody. Sorry I didn't get to the last couple questions there, but if anybody has any questions, my contact information's on the screen, and I think Chris is going to join us again. I should have turned on my my video here. I was answering questions with my slide.
Oh, no, that's perfect, Eric.
Thank you.
Thank you very much. I mean, I think you really did deliver on providing us with a new and different lens, both of you know, the current state of cybersecurity and where it needs to go. And for me, what was fascinating, I was thinking about our yesterday. We saw that the likely rollout is certainly in goods and services, is in airports, airport authorities, and maybe delivery drones. And so what you really articulated here, in my view, is just a whole different way of operating and thinking that airport authorities, communities, and others that will be operating these are going to have to think about procurement practices, regulatory audit, the whole responsibility and the chain of responsibility and all of that. So thank you very much for that great presentation, Eric.
Awesome, thank you.
Okay, thanks so much. So just very quickly, just a couple of housekeeping items before I introduce our next speaker. Again, my name is Chris Gillis. I'm the manager of Applied Research Business Development at Durham College, and we are part of the Durham Regional Technology Development Site in the AVEN network, and I'm your MC for today. If you've just recently joined us, I just want to remind you that you can put any comments in the stage chat box that you'll see to the right of your screen. That the speaker bios and information are on the event website, so please visit that, have a look at that, and if you're live streaming, please come and register and let us know that you're watching us, and again, all of these proceedings are being recorded and will be available on the RTDS websites after the event. So I just want to now introduce our next speaker, and we're going from maybe a slightly terrifying view of where all of the data is and what we need to do with it, I think, to a very interesting perspective on the treasure that resides within data. And so our next presentation is titled The Smart City Waste Management, and it's a very interesting, I think you'll find, case study really on the power and insights for services and goods movement that can be gained by data. So it's my pleasure to introduce Mark Majewski. Mark is the Senior Vice President for or at Innovex. And so Mark, I'm going to hand the stage over to you. Oh, Mark, are you there?
And good morning.
Perfect, Mark. Good morning. And I'm going to hand the stage over to you for your presentation.
Thanks, Chris. Today, I'm doing a presentation for you on what's happening with moving goods and services in the city of Vancouver. And what I want to do is demonstrate to everybody that this technology is, you know, people talk about it being far away, 5 years away, 10 years away, but this is state of the art. This is what's happening today. And through this demonstration, I'd like to pass along some learnings that we found while we were going through. So first, this is William Clay Ford, the chairman of Ford, and it's pretty clear what he has to say, and that the mobility model that we have today simply does not work and will not work tomorrow. And everybody's talking about smart cars, but not many people are talking about smart roads, smart infrastructure, smart hospitals, and all of these systems need to be connected to make a connected community. So what I want to demonstrate today is a couple things. First of all, that your data needs to be architected so that your city or company can be smart. This is the way of connecting all those pieces of data that you have that are best of breed or that are existing, but you need to create an API to connect all of these together. And you also have to realize that when you start connecting all of this data together, it actually turns into a profit center, not a cost center. So autonomous vehicles, people think is a transportation issue, but it's not. It affects everything. This is a picture of suburbia, and in suburbia, you can see the area of parking and parking lots. And you can imagine if this could be wider roads or this can be new buildings, how that changes everything. And people talk about vehicle to vehicle, but it's vehicle to pedestrian, it's vehicle to home, it's vehicle to grid, it's vehicle to infrastructure. And also, let's not forget, it's infrastructure to everything. To make this work, it's just not the vehicle, it's all the other systems. So that being said, first, there's an architecture that needs to be created. And the old method of designing it was one big data lake, which is a great honeypot for hackers, and one big piece of software, which really does not work. The system needs to be architected where this could be SAP or Oracle, this could be Geotab Telematics, this could be city taxation, this can be many different software systems, and through an API or a data creek, we move up to a level where we do the business logic through microservices. Or think about this as, an Apple phone where you have the OS system that's secure and controls everything. And Innovex does OHIP records, we do medical, so we understand how you design ethics and security first. And then you start putting apps in place. And these apps will pull information from traffic and from weather, and that gives you a totally different picture. So you have all these microservices which you can turn off, turn on, remove, add on to, and the whole system stays live. Then to whoever the user is, you make a custom interface with what is it that they need to do their job quickly and well. So this is the data architecture that needs to happen in a city even before you start talking about autonomous vehicles. Once you start connecting these pieces of data, you start getting enough data where you can start predicting. And if you can start predicting where traffic is, where things happen in your city, you can start preventing those things from happening. And this is really important because you're moving from hindsight to foresight. Once you can prevent that from happening, then you need to pivot the organization in real time so that everybody starts moving forward. And pace is also, we found, very important. There's a lot of times we work with companies or municipalities where one group, whether that's IT or business development, they move quickly and the rest of the city stays behind. And you have to empower the entire organization to see these changes. If data comes to the person providing data back to them, then suddenly they provide you good data. And this is important to remember, these 4 pillars. So let's talk about what's happening in Vancouver, where we co-developed this over the last 3 to 4 years. And this is a system that can go autonomous now for street cleaning and things like that. But it's a system that was developed by both of us so that we can do a lot of different things. And I'm going to show you screenshots of this. But the value that's created is the visibility into real-time locations and data of everything that's going on, easy visualization of the problems, because usually the problem happens between two pieces of software, whether that's SAP and telematics, it happens between them, not in them. So you have to have a way of connecting these. We have to digitize the processes so that more and more APIs can be added, and that you have mobile devices involved too. So you start thinking differently. And that's really a key here, is to create a culture of collaboration between the city workers, the unions, the software vendors. Everybody needs to collaborate for all of this to work. So these are two screenshots of what's happening yesterday in Vancouver. And you can see every single one of their trucks and where they are. And every roughly under 2 minutes, this is updated. So everybody knows where everybody is. They're broken up into routes in the morning as to where they're going to drive. They're broken up into beats, small teams, so they can work together. So in case one team finishes up before another team, there's communication between the vehicles and they can go help. So everybody comes home at the same time. They can look at fuel. They can look, if this were to be electric vehicles, where they need to stop to maybe have lunch and charge. This is all interconnected. So we look at the time of year, the weather, Google traffic, all of these to route these trucks. And these trucks do not make left-hand turns. These trucks have been working very efficiently. And the number that the city of Vancouver uses, at least in this sanitation, is they save approximately $60 per day per truck. So that's approximately $2 million for the city of Vancouver. So this is making the money. Then you can go deeper into one of the vehicles if you wanted to. And from one of the vehicles, you actually can see the route that it's doing, that it is completed 383 of its 1,000 pickups. So it starts to let someone know the information deeper if they need to go deeper. This is another picture of what's happening in the city when the trucks are driving around. And some people will say, well, this is strange because Process Legend says you're more than 100% complete. But what we do is look historically as to the garbage pickup. And if the garbage pickup seems to be greater and greater and greater, that's a sign that the area is densifying, that maybe there needs to be a different tax space, maybe something else needs to happen. And this is how integrated the system is becoming to pull taxation information, mapping information, garbage truck information, everything together so people can make decisions. A supervisor can then look in even more detail if they wanted to at each vehicle. They can see what percentage of the routes are completed, what's happening with the trucks. They can also go into work review of each single truck to see when did it start, how's it doing. And you can see we're even providing machine learning or AI predicting what's happening, where they are. So this predictive matter is very good when a new traffic accident happens, when a tree falls and the routes have to change, when a truck malfunctions and a new truck has to come into it. You need this live system to correct everything. And then you can see that you can drill down into a certain vehicle and get even more information as to what's happening with this vehicle, that it's in green bin and, it's going to do these 4 trips today. What we also did with the city of Vancouver is we created a mobile app that sits in an Android tablet within the truck, but also can sit within a handheld device. And the trucks that do waste management in Vancouver have cameras that look into, for instance, the bin when it's being emptied to make sure there's no propane tank or something that shouldn't be there. And if you think of it, the city truck, the garbage sanitation truck, drives pretty well the same route each week or two. And because it's doing that, now the driver can become the eyes of the city. He can tap here on his tablet when the vehicle is stopped, and he can put in remarks to say, fence is damaged, new graffiti, there's a pothole, a tree's down, there's a vacant house. All of this information now can be put together and sent to the right areas of the city so that people can then act upon it. What you're seeing on this screen here, these little X's, and the city of Vancouver is now moving to RFID garbage cans, just like Burnaby. So they will know whose garbage can they're picking up, how heavy it is. It will give them even more information. But this is actually driver knowledge. So the driver can click here on this X and put in something to the effect of, you need to turn the truck around and back down this alley, because if you go forward, there's no way of turning around and getting back out. So this becomes a database for new drivers. Or they can put an X in and say, something's wrong with the city's mapping. Something is different now, something has changed. So it becomes a knowledge base. And in connecting all the different parts of the city, we also connected to the city of Vancouver's 411 call system. So that call now can be routed right to the truck. So as long as the truck is still, the waste management person can click, and if that complaint is that a garbage can was missed, they are maybe close enough to pick it up, or maybe they already went by that street an hour ago and that garbage can wasn't out. But they can answer all of these things on the fly, and they have gone from almost 200 missed calls a day or missed garbage cans a day to just a few per day now. So this is making, the municipality, the people happier. And please remember, if you're thinking of a system like this, think beyond garbage trucks. This can be snow removal. This can be delivery of food. This can be all kinds of things. We're just showing you an example of what's happening today. Through this system too, through this button, one garbage truck person can communicate to another one in case they're finished and they can go help someone. By the time they get there, the routes have been split up into what's called beats, and they can all do their job together and be done quicker. We also, for the city of Vancouver, because this is now a digital model, we even simulated with the unions putting in an extra shift of garbage trucks. And we showed that the extra shift of garbage trucks with hiring people will actually save the city $1 million a year. So you now have a digital model where you can try different scenarios to see what would happen. This is a live picture. I'm not sure how well it's coming out for you, but you can now see where idling is happening in Vancouver. So when the system or our manager can see where the idling is, we can reroute the trucks to make sure that they're not going down main streets that have traffic and vehicles are idling. During rush hour or during certain other periods, we can redo the routes to save them fuel. And they do save about $400,000 a year in fuel. We also provide them with filters so that they can take that moving model and then filter out certain locations, certain parts of the city, certain parks, and they can start to analyze to understand what's happening in the city with traffic management or other things that's creating these problems. And of course, we can dashboard it differently to different people in the city, because maybe somebody wants to see fuel efficiency. And for many municipalities across Ontario and then into BC, we also do things like carbon capture. So we look at the baseline and we let the city know how much they're saving in carbon according to the Paris Peace Accord. So you can see, Climate Accord, excuse me. You can see if you provide the right dashboard to the right person, suddenly their job becomes much easier. We even, because there are geotab devices in their trucks, we can even monitor the different trucks. And as you can see, this is the range of tire pressure that should be in the trucks. And you can see here's one that's correct, but you can see 3 others that are not correct. So for health and safety, this becomes a proactive health and safety issue where we can pull off that truck and make sure that tire is correct before it's loaded up with even more weight and could cause an accident. And then, you create simple dashboards like you would in a car that all you really need to quickly look down is see your speedometer and your fuel. But then if you want to look deeper, there are other buttons you can go down and get more and more and more data. But each person in the city has just the dashboard that they require. And the person that's looking at fuel can monitor fuel by month, per day, by vehicle. You can also start doing analytics so that you can watch where people called in on your 311 calls to see where they dropped off or where they said garbage was missed, day by day by day. And you can see some days are better than worse. And even sometimes the routes are beyond where they're picking up today. So people call from the wrong areas. And you can start taking this insight to make your citizens happier and, and obviously save money. Or you can make the citizens be able to see this map so that they can see where garbage pickups have been missed. They can see where garbage trucks are today, or where are the snow plows and what have they completed and when are they coming. This becomes a connected community, and a connected community is a smart community. This is another routing visualization that we did for the city of Vancouver, where down here is where the trucking station is, where they dump the garbage. But you can see as they're doing the route, the heavier the truck gets, the worse the mileage is. So with this type of knowledge, why not reverse what they're doing and start the truck at the most distant part where the truck will get better mileage. And as it gets heavier, it gets closer to the transfer station. These are all, new live insights that we do. And once we do it, we now have predicted it. So we can move to pivoting where there's more real-time information, explain to everybody what we've done, because maybe there's other parts of the city that can take advantage of things like this. So I'm going to come back to good old William Clay Ford here and kind of recap or redo what we were talking about today before we get into some questions. And truly, cities are, challenged on this autonomous vehicles, autonomous movement of goods, what will happen. And I think the system, the knowledge here that we're trying to show is the data all has to be connected before this will work. You're not just going to buy an autonomous street cleaner and suddenly it's going to work in the city. What we need to do is understand how the data is going to come to this vehicle, what data the vehicle is going to give off, what data is missing, how do we secure it, how do we make sure it connects to everything else around it. And that's when you start getting a connected community where you actually, design the data architecture first. And that the city of Vancouver has now taken a stance that it will not purchase any software from any vendor that doesn't have a robust and good API. API allows the software to talk to each other, to exchange data, to give information. It's becoming an API-centric software city. So with that, it can become greener, it can become more efficient, it can remove modules, add modules quicker, and have software like Innovex's that is overviewing everything and providing knowledge from the shared services. And I think the last point that we learned in our journey going down this city of Vancouver and with other cities is really, it's not a canned solution. Every city is quite unique. The unique part is cities help each other. So if you call Vancouver, they will take you down their journey and tell you where they're at. But it is this collaboration that needs to happen. It is all parts of the city talking together with the private sector, with the unions, with the software. And this collaboration starts making a connected community, which then in turn will make a smart city. So I'm going to open up the question area, if I may. And just looking at the questions now, there's a question here that what are some of the measures taken to deliver redundancy and ensure business continuity and downtimes? Well, just like the previous speaker, Eric, you always want to get your information from more than one device if possible, more than one sensor if possible. So the redundancy is to get the information from multiple sensors, just like a car. Don't just believe the camera, don't just believe the LiDAR. You want to have different systems telling you that information. And once you have the different systems telling you that information, then you can start building in redundancy because your failures are not at one node. And the redundancy then becomes, difficult to penetrate because you've also made a digital model. So you can test things before you actually make it go live. Next question here, does Innovex solution include AVL or does it integrate with existing AVL solutions? How is the data shared in real time and the conductivity method at the vehicle? So the conductivity method at the vehicle today, when the vehicle is a waste management truck, is through the 3G, 4G network that is part of the Geotab Connect system, so that we can communicate through that system data in and out. The information coming from the garbage truck isn't exactly real time. It's about 2 minutes delayed. And with that 2 minutes delay, it's pretty good. And we did not start with a live system that provides all this information in real time. Suddenly, we work with history. We look at all the data, we work with history, we see when accidents happened, for instance, what were the involvements, what happened with the other data when this incident happened. And from that, you can start predicting. So we always work from the past to start looking at the future. What is the process in developing these multiple dashboards? Is this all a custom solution for Vancouver? The answer is yes. It is custom for each person because what we've learned with dealing with large companies is really it's empathy at the node. It's talking to a nurse to understand what a nurse does and what she needs to see on a dashboard, because we do healthcare systems. It's talking to the sanitation driver to see what is it that they really want to see. And with this type of custom dashboards, you develop it once. It may take you a couple days to pull in all the data streams, but as you develop it once, it then becomes automatic. It refreshes unless, there's a problem, and then you go through a normal, ticketing item if there's a problem. But usually when it's designed once, designed well with empathy, so the data comes also back to the driver, things go really well. Next question is all the data from the trucks, not the infrastructure, or both? It's actually coming from both. So there is traffic information, the lighting information, the traffic signals. There is information from the waste stations How much did the, truck weigh when it dumped its load versus how much did we predict it would weigh, even though there is a small sensor in the arm that lifts the garbage into the truck. So we are doing both systems, infrastructure, I to X plus V to X. Is this integrated with MyGeotab? Yes, this is actually on the MyGeotab page. And interesting to note that in 2016, Geotab actually bought its global positioning plus dashboard presentation from Innovex. So we're actually closely linked. We don't have to work with Geotab. In this particular case for the city of Vancouver, we did, but they get to see it through their MyGeotab tab. And we just overlay all kinds of extra information that gives them wisdom. Next question is regarding garbage collection. Did you face issues with security breaches and how did you resolve? Because we designed in ethics and security at the beginning of the design, this is, you always start in quotes at the end and then design the workflow. We put in the same type of security and ethics systems that we use when we do healthcare data in hospitals. So it was designed at the beginning. We constantly get audited because that's part of the City of Vancouver system, but we have not had a failure or a corrective action yet from their security audits. How does your system support interoperability from separate fleets or different fleets serving the same area? Well, again, if the fleets are all using Geotab, that's quite easy to do. If the systems are using different GPS systems, we deal with pretty well all of them. So we can integrate them and put them on one dashboard. So yes, we can deal with different systems, different camera manufacturers, different sensor manufacturers. We do not make the hardware. We just deal with the data. So the last question, I believe, is that we'd like to hear my thoughts and readiness of other cities and opinion on the technologies and what are the barriers and what would we recommend. So we see that City of Vancouver is ahead of the curve. They truly have a vision and people that are creative. And there are similar cities like the City of Vancouver that actually the City of Vancouver is helping teach so that they can not make the same mistakes and learn from the methodology that the City of Vancouver took. But we also see that there are cities that think that open data is it and that's all that's going to happen. And truly, it's the innovation that has to happen. It's creating that culture from whatever it is and working together. Because even in a smaller city, if there are trucks from a private company that have, for instance, Geotab sensors, why can't that information be shared by that private company to the smaller municipality? This is all collaboration. This is all working together. So it's, I think, having an open mind to what can happen. And I'll give one quick, item that happened in Oakville, where I live, where the mayor wanted to put in sensors to see whether it's raining so that he wouldn't have to water the parks and could cancel soccer games. Where all we needed to do is put a geofence around Oakville, through a Geotab sensor, see if the truck windshield wipers are on for more than 20 minutes, and we can send an email to the mayor saying it's raining or to somebody else. A system that costs nothing. And this is keeping an open mind, creating open innovation, and having that spirit of collaboration. So I thank you all, and you've seen my name and connection up there. So if there's any more questions, please feel free to reach out to me. Thank you so much.
Thanks very much, Mark, for that. That was a great presentation, and I think you really delivered on your promise to show that data is really a profit center. It's certainly a cost reduction center. So thank you again for a great presentation, and I would encourage any of our audience who wants to talk further with Mark, you have his contact information, and remember Mark's bio and contact information will be in the event website. So that's great. Thanks so much.
Thank you so much. Thanks.
So next, we have again a couple little housekeeping issues for those of you maybe who have just arrived. If anyone, my name is Chris Gillis. I'm the manager of Applied Research Business Development at Durham College, part of the Durham Regional Technology Development Site and the AVEN Network, and I'm your MC today. I just want to remind you, if you have any questions, please put them in the chat. You can find that on the stage chat to the right of your screen. I remind you, this is a collaborative event put on by the Hamilton Regional Technology Development Site and the Durham Regional Technology Development Site. So thank you very much for being here today. Next up we have for you is a short video of one of the AVEN client groups. I think this one is actually from the Hamilton Regional Technology Development Site, and it's IRIS R&D Group. And IRIS is a privacy-centric smart city, a privacy-centric smart cities hardware and data platform company, and they offer an end-to-end solution. Let me just see here. And yeah, they offer an end-to-end solution that offers efficiencies and a higher level of service. And I think I'm just going to put my camera off and I'm going to let this play so you can see it.
A recent study of CAOs of cities and municipalities across the country found that there's a real problem deploying technology and engaging their staff. Our solution enables them to do just that. It enables them to capture actionable data and redeploy employees in more value-added positions.
5G technology is a game changer for us. It allows us to transfer a huge chunk of data much faster than 3G and LTE technology, which in turn will help us service our clients that much better.
By introducing 5G technology into our services, we can provide a real live stream service to our customers so they can acting based on the data more frequently, more faster, and also in real life.
5G is transforming how Canadians live, work, and play. Robust connectivity will propel IRIS as a global leader in smart cities technologies and will enable us to create safer and smarter cities for all Canadians.
Great, and thank you for that. I did want to add that was deployment of their technologies using the 5G network in the city of Toronto, and that project was supported through the AVEN network. So I would also like to just draw everyone's attention to the fact that International Women's Day is coming up on March 8th, and we want to certainly acknowledge the women in this industry. And I can certainly say that our team of women working behind the scenes on this event have done a spectacular job, and the event would be nowhere near the quality that it is without their great support and skill at doing this. And as well, we are pleased to have on our next panel Dr. Igjot Sani with us for that discussion. She's an acknowledged expert in V2X cybersecurity and is certainly, I think, the force behind the Ontario Women in Cybersecurity affiliate and the University of Windsor student chapter of Women in Cybersecurity. And if you don't see them just yet, you will see URLs to both of those websites, and I would encourage you to visit them, have a look at them, and encourage the women in this industry that you know to look at them so they're aware of it, and any young women who are looking to take this up maybe as an area of study to look at the student chapter in this. So next up, we have our panel discussion for this, and I'd like to introduce my colleague at Durham College, Ali Hirji. Ali is our project lead for the Center for Cybersecurity Innovation at Durham College and the the Artificial Intelligence Hub. And Ali's very active in this whole area and has done multiple projects in all of this. So I'm going to hand things over to Ali, who will handle the panel introductions and the discussion that follows. So Ali, stage is all yours.
Fantastic. Thank you so very much, Chris. Chris, I'm going to use you as my AV, or somebody in the chat who can let me know whether you can hear me okay. And if I get the thumbs up, then I will proceed, assuming that I haven't heard anything back. Yep, I sound great. Thank you very much. I don't often get that, but thank you for letting me know that once in a while I sound great. Much appreciated. Chris, thank you for the introduction. As you mentioned, my name is Ali, and I'm not going to waste any time in getting into the discussion today. I'll set a little bit of context for everybody first so that we kind of know what territory we're getting into. To begin with, before we begin the discussion, I think it's important for all of us to go back to about 2 weeks to 3 weeks ago. Many of you would have remembered that there was an attack on the water system in Florida. Now, there was a lot of conversation about what could have led to this attack, but the reality of the matter is that access to a human-machine interface remotely was most likely what realized this attack. To put it even more simply, people within a particular department shared the same password when it came to TeamViewer, TeamViewer being a tool that you use to remote into your machine. Somebody got a hold of that password, a bad actor, and suddenly now they can remote into a machine. And one of the workers at the plant saw it for themselves that a third-party actor was coming in to manipulate certain elements within the human-machine interface. That was stopped, the breach was detected, and situations were put under control to some effect. However, look at the devastation that is possible when you think about smart connectivity. When you think about HMI, human-machine interfaces, look at some of the things that can happen just by dropping your guard with a simple thing like a password. So today what we're going to be doing is diving deeper into these critical infrastructures and seeing how we realize smart communities and smart technologies and connectivity, and realizing the multiple vectors of attack that have now come forward. The team at Parabellix brought up an interesting point, which is before we were very hell-bent on the perimeter, which is don't let anybody get your device. But with autonomous mobility and with autonomous solutions and connected vehicles, we literally are bringing the device to other people. We're leaving devices open because we have to collect data. A very interesting point brought up by Parabellix Security earlier on in the day. There's a reason that critical infrastructure is seen as one of the core areas for cybersecurity concerns in Canada alone. And it's not just about the technicalities, it's about the people and the process as well. So joining me today are individuals who are in need of no introduction. In fact, these are individuals that have brought cybersecurity and autonomous vehicles and connectivity to our attention here in Ontario. I'm not going to waste any more time, and I'm going to introduce them, or rather have them introduce themselves, beginning with Dr. Igjot Sani. Igjot, can you introduce yourselves and tell us one thing about this space that excites you? Igjot?
Thank you so much, Ali, for such a great introduction to the topic. And I'm Igjot Sani. I'm in University of Windsor. I'm assistant prof in the School of Computer Science. And as part of my research, I work on the V2X privacy and focus also on the security aspects and look for the potential threats and risks in these standards and the developing standards that we are having right now. So what excites me, it's the I think the aspects of the connected vehicles touches our life or will be going to touch our lives directly. And I feel it seems like it's a very sensitive topic and needs a lot of people to be working together on this. And that's why I'm into this.
Fantastic. And Ekjot, for the crowd, I will let them know, the saying, well done is better than well said. The achievements that Ekjot has behind her are truly remarkable. And I recommend to everybody to take some time to take a look at some of the initiatives that she's a part of. Ekjot, thank you so much for joining us. I'm going to go over to my colleague over at Ontario Tech, Khalil. Please introduce yourself and tell us, similar to Ekjot, tell us a little bit about what got you thinking about autonomous vehicles, smart infrastructure, and security. Khalil?
Thanks, Ali, and hello, everyone. So my name is Dr. Al-Khatib. I am a professor at Ontario Tech University. 10 years ago, we started working on security for vehicular ad hoc network, which right now it changed the title, became Connected and Autonomous Vehicle. The interesting part that got me into this field are basically the security elements that are involved with connected vehicle. I mean, you look at connected vehicles right now, they have so many codes, they have so many electronics in there, and many of them could be accessed remotely for added features. So it's not hard to start imagining what are the security and the privacy implications. Forensic work could be done on the vehicle, but mostly, like, what are the security? What are the things that can go wrong with the vehicle when you open it for remote applications? And that what got me thinking into the domain of connected vehicle, and what are the potentials, especially when you talk about data and vehicle and things that are moving around. So that's what got me into the field.
Fantastic. And for those of you that are watching, our friends at Ontario Tech have a fantastic master's program in cybersecurity, and Dr. Al-Khatib, or as I call him, Khalil, will also be speaking with me along with Ekjot at Canadian Women in Cybersecurity next week. So Khalil, always a pleasure to share a stage with you. And I really agree with you that hackers hack systems, but the experts hack people. And you really need to understand the people that are using these technologies. So thank you for that. Danny, my man, my mentor in the space of cybersecurity. We live in a very strange time. Our kids talk back to us, but so too do our machines. Tell us a little bit about what you do and what gets you thinking a lot when you think about smart infrastructure. And you're on mute. Somebody had to do it, and it was Danny.
Well, and you're right, I'm on mute. Sorry about that. Thank you so much, Ali, for having me here. Good morning, everyone. And yeah, so I'm a professor at Durham College, at the same time at Trent University. My area of discipline involves basically data privacy compliance, as well as vulnerability management and penetration testing on the cybersecurity field. To Ali's point, I would say, in terms of connected autonomous vehicle, there is a new service model that's coming up, which is a mobility as a service. And this got me thinking that along this model, we can automate much of the issues and risks that are present in the present CAV infrastructure nowadays. This particular model can define the framework, can define the policy, the standards, and the protocol. So, and it's still not yet a saturated field. So yeah, so it's quite exciting to be in the forefront of developing these protocols and frameworks.
Absolutely. It's a growing field, a nascent field, and to be at the forefront of setting up frameworks. For example, we often talk about the NIST, the NIST framework in cybersecurity. We talk about different standards, and it seems as though we are pushing towards a new set of standards and regulations when it comes to smart infrastructure and autonomous vehicles. So let's jump into the discussion. And Ekjot, I'll start off with you, go to Khalil, and then come to Danny. Ekjot, can you help us understand a little bit about when we look at communications between smart infrastructure, let's say a connected vehicle, and an endpoint, let's say a mobile device? What are some of the things we need to be looking at? We've moved beyond radio communications where it's all cellular based. Can you give the audience a little bit of an insight into what do we look for in these communication protocols?
So, yeah, so simple in a way that we were having the internet for the mobile devices, and everything was connected through the base stations, or in a way that that was somehow centralized or connected through a mesh network. But what we are going to see now is the segment of the Internet of Things, where we are going to have more of the ad hoc networks on the spot forming the network itself. And along with, for example, this is one of the use case, V2V connect communication, which is vehicle-to-vehicle communication. Having the vehicle connect with the neighboring vehicles in a space of 300 meters range, that gives a completely different kind of network, and also give the different set of protocols and technology that we are going to use for this. So that changes what we were doing. It's more like we are piggybacking on what we already had, but actually enhancing it in a way so that we can make new use cases and then leverage the connectivity. But it comes with a new set of threats and changing the entire landscape of the threats and the risks. So now what we are looking at is not just the connectivity. We earlier had base stations. If we are connecting home, like smart home is having one Wi-Fi center. So if there is a problem, it's with we can disconnect that internet at home. But what we're going to do once everything is connected on the road, that is on the smart city aspect, and if there are Internet of Things within the home, making it smart home, how many of the things that we are going to disconnect or will be making sure that it's secure or not? That's changing the entire realm of security, and the increasing threats are increasing way faster than we can actually cope up with and solving right now. So it's because the protocols and the standards are still in development. Thank you.
Absolutely. And Igjot, I think you've highlighted the point that we often talk about when we talk about the Internet of Things. We need to be looking at it from a lens of the Internet of Threats, because there's multiple communication systems that are running at the same time, which brings me to Khalil. And speaking about this idea of threats, can you help our audience understand a little bit about, now that we have this new models of communication where one device could be speaking to multiple devices at the same time, what kind of positions do we see data in? We have data at rest, we have data in transit. Can you help our audience understand a little bit about what do we mean by data and how it moves through these communication protocols? And now Khalil had to do it, and he's on mute.
I have to do it because I think we were instructed to clearly just be on mute when you're not talking.
Oh,
anyway, so to add to what Igjot started saying is that when we start talking about vehicle-to-vehicle communication and remote access to vehicle, it's true that we start having extra features, and it's making life easier. But you start thinking about the security implications in there. So the fact that you can start using data to tell drivers that there is a congestion somewhere, or there is object on the road somewhere, or the vehicle down the road is braking, so prepare to brake. That creates a new security challenges in there. So it's true, data is becoming very important, but at the same time, the potential for misuse of that data is becoming bigger. So there are new applications, definitely. There are new features, additional features that's making life really nice and easy. But thinking about the threats, that what kind of scares me sometimes, to start using the data and using those communications protocol between vehicles to have, events similar to 9/11, but by vehicles. You start thinking, yeah, everybody wants extra connectivity, everybody wants extra data. But I think it's up to the research communities to start thinking, okay, so what would happen if you cause 4 accidents, for instance, around the Toronto area, around 401, 427, and the QEW? The implications are huge. You can block the traffic, especially during rush hours. The implications are huge. So even though data is making things interesting and there are lots of benefits for that, the threats are becoming bigger and bigger.
Absolutely. And I want to work with that a little bit because I think you've really highlighted it's not just data that's in transit or data that's live, there's data at rest. How do we store these data sets? Where are they being stored? Who has access to some of these endpoints? I want to come back to that conversation as well, but I want to bring Danny back into this. And Danny, you're very humble in introduction, but you wear multiple hats. Besides being in cybersecurity, you also play in the world of AI. And you and I have often discussed that there's no AI without IA. There's no artificial intelligence without information architecture. Can you talk a little bit about the backbone and the overall last mile technologies that are there that are now enabling this transmission of data? What do we mean when we talk about 5G systems that are enabling these kind of environments and the new communication advancements?
Right. So one thing that we need to understand when we are developing or deploying CAV and the infrastructure in general is that automation play a very important role in this particular infrastructure, and automation should be implemented across the entire security architecture. So for instance, for mobile service providers, right, automation must expand across all layers of the security architecture. First and foremost, the network must leverage as a sensor some sort of a digital cyber attack tripwire, if you will. So in 5G networks, for instance, network elements are distributed at the edge, and they are correspondingly virtualized, right? So the network's endpoints can be used as a detection spots, right, to send messages back to a, in Australia, they call it the CCP, the centralized control plane, right? So this CCP serves as the brain of the network, if you will, compiling all the inputs from its telemetry, and then deploying the best way to apply remediation and mitigation policies. Now, in the entire ecosystem of this security infrastructure or architecture, if you will, the big data would come in. There's going to be lots and lots of data that will be collected. I believe that part and parcel of that infrastructure, and into a greater extent, the security architecture should be able to collect and provide telemetry on this big data that will be coming in. So that and those other portion of the infrastructure would remain crucial, both the endpoint and the edge point devices.
Fantastic. And Danny, I thank you for bringing the point of telemetry, because quite simply, because at Durham College, for example, we engage with companies like Darktrace, like ExtraHop, SentinelOne, etc. And we talk a lot about knowing a pattern of life with your data sets and knowing how to detect anomalies and knowing how to automate some of those things that are happening in these environments. Lots of data going out there, lots of backhaul infrastructure to support this. Great, we can achieve things. Once what was impossible today is possible. However, we really now need to delve into some examples of when we're seeing smart mobilities, when we're seeing communication metrics happening in new environments, what are some of the threats that we're beginning to see? So I want to take one example. Khalil, we'll go to you, and then I'll come to Igjot and back to Danny. Khalil, you would have seen a couple of, and I know you share some affiliations with the Middle East as I do, you would have seen that in Dubai, they've now made it a staple that at Dubai airport, you do not need a passport, for example. Your face serves as the passport. So there's a picture that's taken, that picture ultimately gets parsed somewhere and scanned somewhere, and then results are given. That is a very interesting example. Seems very convenient in the light of the pandemic. What are your thoughts about when you see new innovations like this? What scares you a little bit?
I have to say that UAE were one of the first countries that even they deployed originally iris biometrics at the airport, and that was 10 years ago. Even with the original work, there were a little bit of privacy concerns, and it's the same thing even with the face recognition systems at their border crossing points. So typically, anytime you talk about biometric systems, you talk about the privacy concerns, and from the perspective that it's biometrics is not 100% accurate. So even fingerprints, even iris, there is still a certain degree of false positive. So so you can track people with this biometric technology, and this is why there are right now, if you look at the Canadian government is updating their PIPEDA regulations related to privacy so that it can factor in AI technologies. But there is also with any new technologies that there are the privacy concerns that are major things. And I have to say, biometrics is not different. I mean, it's been around, they use for some time, and then everybody, most biometric technologies, it's based on AI. So there are a couple of things that are gonna come, basically the privacy concerns, and part of what's coming out in the updated version of PIPEDA, which is basically the government regulations for privacy, is explainability. So that's something interesting to watch, because people under the Canadian law, they're entitled for an explanation of why a certain AI system, which basically biometrics used AI systems, why they came up to a certain decision. So that's something interesting that's coming up as well.
Yeah, absolutely. And to our audience, this push, and Danny, you and I have spoken a lot about this as well, that there's AI and then there's XAI, explainable AI. And this is something where, we can certainly delve into that. So to the organizers, if we could ever do a future session on what do we mean by XAI and opaque systems, I think that would certainly be of interest to this community. But working on what you said, Khalil, Igjot, I want to bring you back into the conversation, because we're seeing very clearly that when it comes to smart connected solutions, smart city infrastructures and connectivity, there's a public sector play, there's a private sector play, and there are partners, the 3P partnerships as well. What is your perspective on strategies when you start to deploy such solutions? They say strategy is the art of knowing what not to do. If you had to tell people who are looking at solutions that are driven by connectivity, driven by transmission of data in these environments, what are some things that you would tell them not to do? What are some things that you would tell them to make sure that they're adequately prepared? Igjot?
So I just want to set the context right. So do you mean if we are just talking about Canada or
let's look at Canada for now, and then if you want, I know you have a international portfolio as well. So if you want to reference one international country as well, feel free to.
Yeah, so why I ask you this, because it's important to set the context with respect to regulation, as Khalil mentioned. It depends on where you are. And earlier we didn't see regulations being that they always played major role, but it's becoming now intensively a big dependency in this ecosystem, that we need regulations, and moving forward we need more and more, and also need the catch up and have that pace where the development of the technology should not be way faster than the regulations. So what Khalil just mentioned is the privacy, and he touched upon one of the aspects that I worked with, and I was always concerned about with the collection of data and passive collection of data, not the active one. So let's say if there is possibility of collection of data, but it's not by some authorized personnel, then what happens to that? And how would you even recognize that somebody is passively listening to the communication and collecting the data and might misuse or use it for any purposes? So that creates a new set of problems, because we earlier have seen that if there is an active attack, then we can actually follow up and have the intervention, and we can check up and have the regulation based on that and can file a complaint, right? But if it's happening now passively, now we don't even know what's happening, who is recording the data and how it's being done. So one of the few things that I would say, like if there are changes, or if there are open calls for changing, there are different RFPs, and also for rulemaking, there are always open calls to give the ideas from open, like publicly you can suggest what do you think, and as customers, you can also say that for commercialization of certain technologies, is it ready for the customer use or not? And when you're building the product, it's very important that you are considering the customer and product, not just the technology itself, because it's the people who are going to get impacted in the end. And when you talk about smart cities and smart vehicles, it's very common to say that security is the safety in these technologies. So please don't underestimate when you're building such technologies, it's going to have direct impact, not just monetary impact, but also it can be their lives are at stake in this technology. So we need to make sure that regulations are hand in hand with the pace at which we are developing the technology within a country. It's very important right now. So in North America, the pace is different than Europe, and then they are different pace than China. So because each country works differently and geographically, it impacts really well, because we can see that we have the longest border with America. So that is going to impact how the international crossing, border crossing would look like. So these are some of the open questions need to be answered, but carefully assessed in the future. And when the people are working on these products and the systems and technologies, they need to pay attention to the bigger picture when they're working on a small piece of this technology.
Absolutely. And I remember hearing a talk some time ago, and I know you've written white papers for them as well with EC Council, and this concept of data migration and data immigration. Very interesting concepts philosophically. Khalil, I see that you have your hand up, so I'll turn it over to you directly. Khalil?
Yeah, I mean, I guess one of the things that was alluded to by previous speakers as well, previous sessions, is the important factor of security testing. Yeah. I think Ingjot and Danny and myself, we work in this domain, and I cannot emphasize more the aspect of integrating security in all aspects of any software feature or product development. When you integrate, when you implement, when you think about security and when you do privacy by design, when you do these things early on, you eliminate so much of the problems later on. So some of the things that we do right now, part of the Automotive Center of Excellence is doing security testing for connected and autonomous vehicle, and even looking at how do we generate test cases for security, specifically for security. And that's very important, because if you integrate security from the beginning, you eliminate many of the problem. And if you think about the user, as Ingjot mentioned as well, is that when you think about the users and you do privacy by design, many of the problems could be eliminated early on.
Absolutely. And I think the proactive security posture, which is a perfect segue to bring Danny back into the conversation. Danny, before I hand it to you, I know we've got about 20 minutes left. To our audience, if you have any questions, please feel free to drop it in the chat, and I'll make sure to weave it into the discussions that we're having. Bunch of questions have already come up in my mind, so I'm sure they've come up in yours. Danny's taking both what Ingjot and Khalil said. You work also in the field quite a bit with different firms, and privacy impact assessment, something that you definitely focus on a great deal today. How has the space of autonomous vehicles and connected vehicles and smart infrastructure reshaped your approach to privacy impact assessments? I know you're a big fan of you never release risk, you always bring down the risk level. How has your approach changed to some of these impact assessments, Danny? And Danny's on mute.
And there you go. just like Khalil said, we're supposed to actually mute ourselves. Right. So I guess the question is, so how does this all impact my approach to data privacy and in the greater context risk? I think, without sounding too pessimistic, I would say being realistic, it has become more riskier, for the lack of a better term. It is important that we understand that the digital infrastructure and the data systems have to be in place before we put all of this, CAV infrastructure into motion. And the idea about the V2X, right, the vehicle to everything kind of model. We do expect that the vehicles, the CAVs, are not just going to connect to the large data centers, right? They're going to connect practically to the IoT backbone. So having the right digital infrastructure and the data systems and doing risk triage and embedding that as part of the design is going to be very crucial. It's not going to be easy, but it's going to be a bitter pill to swallow, to say the least, but it has to be done because lives are at stake here. right? This is not just, a new web app that we're developing. We're actually automating things to provide a more, relaxed environment for people, but at the risk of what, right? Another thing that we need to also be looking at is the next generation network management, the incident response capabilities, right? We have to collaborate with industry to trial real-time data exchange and open data platforms. That's the key. Without having the go ahead out of the test for this, we should not, just dive right away. And risk, should I say, risk management should actually form part of the core process in putting this into execution.
Absolutely. And I think, that aspect of it getting more riskier and how you approach privacy impact assessments has become key to all of this. There are some automated solutions to privacy impact assessments as well. And for those of you who want, we've done some work at the Center for Cybersecurity Innovation as well with some automations around privacy impact assessments. But enough of that. Ikjot, I want to come back to you because I actually got a question that came into me from Twitter, and I'll reword it just a little bit from a friend of mine who sent me this. And that's like, the question literally reads is that what kind of lessons can we learn from something like the Sunburst SolarWinds attack, which really was, an explanation of or a case of software patching and some complacency in that process. But if I can reword that question a little bit for you, Ikjot, it's when you look at these kind of attacks which are happening through software patches, for example, what does that tell you about our state of readiness for the new types of threats we could face in the autonomous sector? Ikjot?
Well, if it's scary, then I would say it is scary, but it is evident that what state are we at right now? We are dealing with the IT security risks or threats, and also the OT security threats. So the things that we know already, we are still trying to figure out the ways to actually implement them, really implement them, because this is one thing to have like compliance versus you are really doing something, right, and implementing it. So these are the things we know. What are the best practices? What are the guidelines? What are the things to follow? And how we can solve them. And still we are seeing that readiness is not there because it's not actually being not implemented on the ground where it's supposed to happen. So actually I would want to allude on the different topic. Would also mention that with this connectivity, we are missing the whole point of supply chain. And that actually is also the part of the SolarWinds that also make you understand that how every little component in the car and also in the infrastructure is contributing in this connectivity. And if you just have that access, and because we always in hackers terms, it's the privileges and the how far you can go and hack and access the data, right, and then misuse it. So if we can do that through a little sensor, which was built somewhere else and was used in one car, now that actually creates a different problem, which we have not yet figured out how to solve that. So does that mean like we have to put some sort of security bubble around each piece of code? Because we're going to write in a lot of pieces of codes for the electric and autonomous vehicles. So that is coming to the point that we are now going to protect and putting each, that bubble wrap. I think that should be the analogy for the piece of codes that we're going to have, but that is the secure way to actually writing the code for the autonomous vehicles in moving forward. That is one of the things. And from SolarWinds, we have seen that it needs to be like followed up from the supply chain, all the different components.
Absolutely. And for our audience, I'm sure you would have heard of SolarWinds. It was kind of like a little bit of a Christmas, pre-Christmas kind of story that populated the news. Take a read about it. And when you start to dissect it, a lot of simple to read articles around how the patches actually caused this to happen. Take some time to read on it, and you'll get to understand how this is not as infrequent as some of us may think it to be. Danny, you had your hand up, so I'll turn it over to you to shed some light on what Ikjot had said.
Right. I just would like to add to what Ikjot actually expertly mentioned about the area about data privacy. Right now, if you're looking at NIST 800 and ISO 27001, and to a greater extent ISO 27700, they have not identified or put in place a specific domain for a vehicle to everything kind of standards or frameworks. So it is important, again, I'm just going to reiterate, before we deploy all of this infrastructure, that we need to first develop a framework and clear policies, standards, if you will, and protocols around three things: data sharing, data privacy, and security relating to CAVs. Unless we have all of that already in place, there is going to be another SolarWinds incident. And oh, by the way, I've worked with a client 2 months ago that was using the specific module of SolarWinds in their infrastructure. Just for everyone's FYI, not all of SolarWinds products were actually part of the breach. Only a specific. There are only 3 submodules. But one thing that was not mentioned in the news article out there is that majority of the breach on the patch was caused from an inside. So there's an insider bad actor that actually contribute to that. So if we can come up with a policy, a framework, and a standard that can also address those kind of potentialities, that will provide a better security architecture for the CAV.
Absolutely goes back to proactive postures. And I do agree, a question that has come in about the importance of privacy and compliance for sustainability of our autonomous vehicle environment. And I would agree 100%. One of the easiest things to do is to deceive ourselves that we've got policies in place, so we're good. It really is about how you apply them, how you test them, and how you audit them. Danny, thank you for that. Khalil, I want to come back to you. Khalil, you alluded to privacy by design, Dr. Ann Cavoukian, for example, but you also mentioned about security by design. And Igjot talked a lot about, we need to move away from developing protocols and prototypes that think of security as an afterthought. It's not just DevOps, it's DevSecOps. For the sake of our audience, can you explain to us, what do we mean by DevSecOps, and what does this mean to a project and, let's say, its budget, for example? Khalil?
So when you are when you are developing a project, so it goes through a number of phases, from the concept phases to the design phase, to the development phase, to the testing phase, whatever. So with DevSecOps, it's all about integrating security into all those phases. So basically, you identify the threats and possible scenarios early on that can affect confidentiality, integrity, and availability of your system. And basically, you go over your system and you go over every component of it, and then you analyze what are the possible threats and risks with that item. And you look at what are the implications, and you identify the risks, and you can basically decide whether you can live with this risk or not live with risks and do something else. So some of the things, this is when it starts coming up. We talk about security. It's very important as well to look at resiliency. I mean, you mentioned SolarWinds, and the stories, all companies will list possible hacks. So sometimes people start thinking it's not a matter of what happened, it's just a matter of when it's going to happen. So systems are kind of even patching, or even if you stay on the top of patching, there are zero-day vulnerabilities that's going to happen. So this is why there is right now a little bit of a mindset shift to look at the zero trust models where, and resiliency. So basically you build your systems so that even if there is a breach, your system hopefully can still act in a resilient way.
Absolutely. And I think this aspect of zero trust architecture and how you deploy zero trust architecture, a couple of months ago, I was doing a session with Bill Harmer from Secure Auth, and to my delight, he mentioned something to the effect of, I think, therefore I am. That's something we used to say before. Today we say, I connect, therefore I am. But it's not just that. It's about once you connect, what are you doing when you're on these systems? And Igjot, I think that's a good area to bring you back into the conversation. Although we didn't discuss this sort of in our prep for the session, I know you can speak to it. And this is this aspect of access management and identities when it comes to connected vehicles, so on and so forth. What's the challenges there like? And can you help our audience understand a little bit when we talk about access management? What are we talking about there? Igjot?
So is this particularly with the identity?
Yes.
And for the vehicles?
For vehicles, absolutely.
All right. So I can just ensure you that fortunately we are not going to use the VIN numbers, vehicle identification numbers. So that's not going to be in the plain text on the communication broadcast. But what the research community has come up with is the idea of using temporary identifiers, using the same model that we use for similar model, actually, not same, for public key infrastructure. For these temporary identifiers, and that creates a new life cycle of these temporary identifiers called pseudonyms. And having that in place, it's used for the identification of each vehicle on the road. And when they are communicating, it uses that temporary identifier rather than saying it's Jyoth's vehicle with this number.
Right.
And because that is the direct privacy risk and threat there. So when you say access control and access management, I think it goes back to the vehicle to infrastructure, because that's where we want to have the access. We are not just going to have the direct ad hoc network communication, because then the vehicle moves really fast and it changes the position and location as it's moving. But rather, when the vehicles are connected with the infrastructure, like we are today connected with the base stations when we are in a certain region, even though we are moving, we are for a long time, we are within the same region. And that there is a connectivity between your mobile device and the base station. That gives the access of the vehicle to the infrastructure unit. Now, I think that should not, that looks scary, but there can be the infrastructure units which may be compromised. If that is the case, then that is one of the potential ways that there is. It seems like the authorized access, but it's not the authorized access. So that is the case which you actually mentioned. And when that's going to happen, it's going to be getting all the information that your vehicle has to give. So that information is, if this is level 3 autonomy we are talking, it means even the controls, because level 3 onwards, we are going to have let the vehicle decides how to move and how to navigate. And so what starts happening at that level, that's why everything we have discussed till this point is important, regulations and all those things, because now if there is access through this infrastructure unit, I'm not even talking the case where the other vehicle can hack. I'm just talking the infrastructure unit, because today we see that and we can understand that better. And if there is a hack or remote access through your vehicle there, then it can actually start making those decisions for you for your navigation. So that is the serious and the most serious risk the worst possible case scenario that we can think of is that in terms of access.
Absolutely. And I couldn't have said it better. Data is the new oil. Data is a new form of currency, and how we transmit that and to whom and who has access to it, etc., all are going to be fundamental in our security and privacy postures. We've got about 2.5 minutes left. And Danny, I'm going to give you the final question, and then we'll close with some concluding remarks. And Danny, when Ikjot was talking about data, how we share this data, so on and so forth, the best data analysts or data scientists are good storytellers. Can you help our audience understand a little bit about some of the social engineering attacks that we're beginning to see because of the state of connectivity we find ourselves in? Danny, a couple of seconds to you, sir.
Well, first of all, the biggest example would be the man-in-the-middle attack whenever data is in transit or in motion, right? So, connected autonomous vehicle is no different. I can already foresee that there's going to be a vehicle in the middle attack whenever the actual CAV is trying to communicate with the data center. Especially, Ikjot mentioned about level 3 and above, specifically levels 3 and 4. This is going to be very crucial. And I'm pretty sure, since there's no standard, we don't even have a protocol that says what kind of encryption cipher that we're going to put in place for data in motion on a level 3, level 4 communication. That opens a Pandora's box right then and there. So in terms of social engineering, again, on the context of CAV, the idea of vehicle to everything kind of opens the floodgate for the information on the vehicle to be shared practically by any appliance out there that's connected to the internet. How are we going to secure that? That's another problem. Are we going to use the basic TLS, SSL encryption that is available out there, or should we use a different form of cipher encryption specifically for V2X kind of model? So those are things that have not yet been discussed, and these are things that we really need to wrap our head around as soon as possible.
Yeah, and I would agree with you that there is a huge opportunity for us as a cohort at this conference to put together some policies and to put together some recommendations. So Danny, thank you for that. We have come to the final few minutes of our time, so I am going to request that we all come to a conclusion. But Danny, I really like that line, vehicle in the middle of attacks. I think that's something that we can play with going forward. In concluding remarks, I'm going to go to each one of the panelists and ask you to make one recommendation. So Igjot, we'll start off with you. If somebody wanted to learn more about the work that you do in autonomous vehicles and security, what's a resource that you would recommend them to?
I work on, I never say that I work on autonomous vehicles. I always make sure that it's very clear that I work on V2X and connected vehicle security. And I follow up with the current standards development and using I use all the papers from IEEE because that's the closest one. And I'm looking and have my eyes on ISO standards coming forward someday on V2X. So that would be my next thing. But also start understanding ISO 21434 standard, because somehow it's going to be overall part of this because it has cybersecurity road vehicles. So now we need to start understanding as an ecosystem what it's going to look like. But for sure, these are some of the resources. Go with the standard resources first, and then understand the architecture, system architecture, and underlying protocols.
Fantastic. As always, very thorough, Igjot. Khalil, yourself, closing comments and a resource that you would recommend to our audience. And the final, you're on mute statement had to be made. Go ahead.
So there is a new standard, as Igjot mentioned, that is coming out from ISO and ACE, the 21434. One thing that as well I should mention that as a final note, it's very important to do to implement privacy by design, do security testing, and if anybody needs any help, we just launched at the University Institute of Cybersecurity and Resiliency Systems, and there is the Automotive Center of Excellence that we could help with security testing as well. So there are lots of resources out there. It's up to the community to seek for these resources and use. Yes.
Absolutely. And Danny, same question to you. Final words, Danny, a resource that you'd recommend.
Well, you and I work with the Artificial Intelligence Hub and the Cybersecurity Innovation Hub in Durham College, where we design, applications specifically for this kind of implementation. So please go to Durham College and look for the AI Hub and Cybersecurity Innovation Hub links.
Danny, thank you very much. And to our audience, thank you for joining us today. I surely learned a lot. I think one of the things that stayed in my head was that do we necessarily secure our systems or build systems that are secure? And I think we need to build systems that are secure. Security doesn't need to be an afterthought. You have to have a proactive posture to security. I thank you again, Igjot, Khalil, and Danny, for giving me the time and the honor to interview you for this panel. I'm going to turn it over to our host, Chris Gillis, for some concluding remarks. Thank you, everybody, for tuning in. Chris, over to you, sir.
Thank you very much, Ali, and thank you for running your usual professional and engaging, informative panel. And again,
My
thanks
pleasure.
to all of our panel members too. I think you did an excellent job in really building on the points from our keynote and from our case study, and certainly for me, and I'm sure for our audience, really I have a much clearer view of the great benefits, certainly in using data, but also the significant risks that also accompany that. And this obviously will have to be well managed on an ongoing basis in an ever-changing landscape. So, Ali, thank you so much for your participation. Really appreciate it.
You're always welcome. Cheers. Thanks again, Chris.
Okay, thank you. So this actually ends the presentation component of our event today. There's a networking opportunity in a few minutes, but I just wanted to cover off a few closing remarks. Again, to thank you, our audience, all of our speakers, and those who tuned in on live stream for your participation in our event today. It wouldn't be as good a success or great a success without your participation. Also, again, I wanted to thank our collaborative partners in this event. This event is presented by the Innovation Factory, Center for Integrated Transportation and Mobility, or CITM, who are the Hamilton Regional Technology Development Site. Our partners, Ontario Tech University, the Spark Center, Durham College, and we are the Durham Regional Technology Development Site, and of course the AVEN Network. Just for those of you who are planning or contemplating attending our event tomorrow, which is the last day, the theme is municipal readiness. You can expect, I think, a very engaging and interesting keynote by IBI on AVs. Are we ready? We're going to have an interesting presentation by SmartCone Technologies, and you'll see how their technology is helping enhance safety with the application of this advanced technology. And we expect to have another engaging and informative panel discussion around municipal readiness with those actually operating and working within municipalities on this. As well, a reminder, if you missed any of the segments today or yesterday, we're going to be sharing those. They're going to be recorded and they'll be available on the both the RTDS websites after the event. And now is an opportunity to meet somewhat face-to-face in this new world, an opportunity for visual or virtual rather networking. You'll see the icon basically on the left-hand side of your screen. Looks like a handshake there. And if you'd like to take part in the networking, just click on that and it will take you to the networking area. And just remember that Hopin will facilitate a 3-minute networking discussion randomly throughout the group. And if you'd like to continue your conversation, just click on the extend before the time expires. So again, on behalf of all our partners and the organizers, thanks so much for your participation today. Hope